Okay, good afternoon and welcome to the Oxford Martin School, and welcome to the fourth in our series of seminars on climate change, a series which extends until May, illustrating quite a lot of the breadth of the issue and also of the activity on this topic around Oxford. Today's speaker is Dr. Rob Bellamy, James Martin Fellow in the Institute for Science, Innovation and Society at the Oxford Martin School. His research focuses on public participation in the assessment and governance of complex and emerging sciences and technologies, with a particular emphasis on climate change. He was the lead author of the UK's first comprehensive climate adaptation tool, and most recently has been involved in the Climate Geoengineering Governance project here at Oxford, exploring ways of governing large-scale technological interventions in the Earth's climate system. So far in this seminar series, we've heard about the energy-intensive nature of our modern lives, about the difficulties of climate modeling and predicting where the climate's going, and also about some of the mechanics of the IPCC process. Today, Rob will address the crucial question of why people disagree about how to tackle climate change in his lecture entitled Hopes and Fears. So welcome to Rob Bellamy.
Okay. Thank you very much, Julian. First things first, I've got a confession to make and a qualification. The confession is I've snuck in an extra word into my title, which is that why people should disagree about how to tackle climate change. And in making it more provocative, I need to make about my use of the word disagreement here. And this essentially relates to the need to bring more perspectives into debates about how to tackle climate change and to enhance the ways in which such decisions are scrutinised. And I'll be exploring this with particular reference to an emerging area of science and technology within the field of climate change, a controversial one, which is climate engineering, or geoengineering, as you might have heard. So I'm going to start off actually with the picture that was chosen for my seminar by the good people at the Oxford Martin School, which is actually turned out to be more appropriate than perhaps they realised. So what we can see here is a bunch of climate change activists who clearly care passionately about how to tackle climate change. And we've got a nice little placard there saying, or proclaiming that we have one planet, we are one people, and we have one future. Notwithstanding theories of the multiverse, I think she's right that we only have one planet. But are we one people, and do we have just one future? Sadly for these activists, the answer is of course no. So we need look no further than people's reactions to the recent climate change negotiations that took place in Lima in Peru last year. And in looking towards the negotiations for Paris later this year, we've got a whole host of different perspectives on this. Our Energy and Climate Change Minister, for example, Ed Davey, has been quoted as saying, this is an agreement that unites all nations, unlocking the door to the world's first global climate deal in Paris. Some members of civil society have been less optimistic about this, and we've got Christian Aid saying that nations have failed to respond to the calls of the public, scientists and investors. The countdown clock to Paris is now ticking. We've got WWF similarly saying that what they came out with in Lima was a half-baked plan. And then, just for good measure, we've got a quote from the Global Warming Policy Foundation, who welcomed the non-binding and toothless United Nations climate agreement adopted in Lima. So what we can see here is a whole range of views, some more optimistic, some more pessimistic. We can see satisfaction with progress that's been made so far, but we can also see dissatisfaction. And interestingly, it seems that the one thing that activists and skeptics of climate change can agree on is that they fear for an agreement in Paris in one form or another. So I'm going to start off with a bit of theory then, just to contextualize the rest of my talk. This is something called sociocultural theory, which was developed in the late 1970s by anthropologist Mary Douglas, and has been later developed by Michael Thompson and Professor Steve Rayner, who's based here at the University of Oxford and will be talking later in this seminar series in May, actually. But essentially what this theory argues is that people come at facts and science and other facets of life in different ways. And this is essentially down to the ways in which we organize our social relations. And this is done through two primary factors. Firstly, something that the theorists called grid. So this is the extent to which our social lives are governed by prescription or authority and order. And the second way is through something that they call group, which is the extent to which our lives are governed by community. And these two important factors give rise to a typology of four basic ways of organizing our social relations. And these are those of hierarchy, egalitarianism, individualism, and fatalism. And presented with the same science, the same facts, you'll get a completely different response from any one of these four different ways of organizing. And Buzz Holling came up with quite a nice typology that went along with this, which he called the myths of nature, which relate to how people perceive the stability or otherwise of the natural world. So for hierarchists, this means that they believe nature is essentially perverse or tolerant, and in this sense, systems can be managed by proper authorities. Egalitarians, on the other hand, see nature as incredibly fragile, and this is represented by this ball in the landscape. So the system here, if the ball is climate, it's perched on the top of this hill, about to fall into an abyss. On the other hand, you've got the individualist perspective, which is completely inverse to that. The climate system is within a very stable basin of attraction, and they believe that no matter how hard you push the climate system, no matter how hard you force it anthropogenically, it won't leave that stable state. And then finally, we've got the fatalists, who believe that climate change is completely unpredictable. So just to go through each of these in a little bit more detail, they each have different ways of perceiving the risks posed by climate change. So for hierarchists, I say, because it's, we've got this kind of ball in a landscape that's kind of more manageable, they believe that proper authority and regulation can sort out the problem. And this is the way of organizing that has dominated climate negotiations for the last couple of decades at least. And this is where the whole idea of a global agreement comes out of. So it's a very particular way of formulating a response to climate change. Egalitarians, on the other hand, risk for them is catastrophe. So they're more susceptible to ideas of, for example, climate change tipping points and abrupt climate change. But their solution isn't necessarily about more authority or regulation, it's about requiring common effort in voluntary simplicity. So this is where things like low carbon living and things like that come into effect. For individualists, risk is opportunity, and their outcomes must work with the grain of the market. So in this sense, a market-based mechanism might be more appropriate for tackling climate change. And that's different to the kind of market mechanism that was peddled by the global agreement, which is a very hierarchical one and not individualist in the truest sense. And then finally, for our poor old fatalists, because risk is unpredictable, outcomes are a function of chance. So they say, why should we bother? Because we just don't know what's going to happen. So with that in mind, we can see that people view the same sorts of things very, very differently. And we need to bring in different perspectives to bear on an issue, otherwise we're going to get something that's only formulated from a particular perspective, such as the global agreement. And I'm going to explore this now in particular relation to climate engineering, which you may or may not have heard of. It's an emerging field in climate change policy and science. They're essentially defined as deliberate large-scale interventions in the Earth's climate system. And they've recently emerged alongside mitigation, which is reducing greenhouse gas emissions, and adaptation, which is about reducing the impacts of climate change, it's emerged as a third possible category of response to climate change. But importantly, it's emerged as a response to the perceived insufficiency of those first two options. Firstly, that mitigation efforts to reduce greenhouse gas emissions have so far proved, well, they've hardly done anything. Emissions have gone up. And secondly, in response to adaptation, there are particular climate risks that we might not be able to sufficiently adapt to. And this relates to the kind of perceived idea of a climate change emergency, which is often born out of the idea of climate tipping points, that we may come across a particular change in the Earth system or the Earth subsystem, which might be very rapid and that we might not be able to adapt to quickly enough. So climate engineering is essentially divided up into two types. We've got carbon dioxide removal technologies, which are essentially about removing carbon dioxide or potentially other greenhouse gases out of the atmosphere and sequestering them in long-lived reservoirs. And the second category, which is somewhat more controversial, is solar radiation management or sunlight reflection methods, depending on how you want to frame it. And this is all about reflecting a proportion of sunlight back into space. So just to give you a little bit of flavor of the sorts of technologies that reside under this category of disparate technologies, this is a rather nice diagram that was used for a public engagement with geoengineering, incidentally, back in 2010, called Experiment Earth. So this first technology is called air capture and storage, which is essentially a black box technology that would see a technology essentially scrub the air clean of carbon dioxide, and then they'd store it in underground reservoirs such as disused oil wells. Secondly, one might include ocean iron fertilization, which is a technique for seeding the oceans with iron filings, which would in turn start an algal bloom. And the idea is that when algae grow, they use carbon dioxide and absorb it, and then the idea would be that when they die, they go to the bottom of the ocean and take the CO2 with them, thus keeping it out of the atmosphere. And a third, more conventional carbon dioxide removal technology is afforestation, just on a large scale. And there's debates about whether this should even be included as a geoengineering or climate engineering technology in the first place. On the solar radiation management side, we have things like marine cloud brightening, which is essentially about launching salt particles into clouds to make them more reflective and brighter, thus reflecting more sunlight back into space before it can get trapped in our atmosphere. A second one, which is perhaps the best known climate engineering proposal and one of the most controversial, is one called stratospheric aerosol injection, which is about launching reflective sulfur particles into the stratosphere. And some have compared this to natural volcanic eruptions. And then finally, as an example, we have desert albedo modification, which is basically slapping a large mirror on the Sahara Desert. But there are less strange options in that category as well. There's a number of albedo modification techniques on the land surface, which would see more sunlight reflected back into space, which includes urban albedo modification, basically painting urban areas white, crop albedo modification, which is genetically engineering more crops with a higher albedo, and so on and so forth. And then perhaps the funniest of all, in the top right corner, we've got space reflectors, which is putting mirrors in space. So we've got a whole range of different technologies under this category of climate engineering proposals. So I just need to provide a little bit more background and context to the discussion about climate engineering and indeed of climate change more generally. So climate change is not a problem that we would consider to be normal problem-solving science. It's not defined by low stakes. It's not defined by relative scientific certainty. and it's not characterized by an agreement of values. It's instead what we social scientists like to call postnormal science. So it's essentially in the realms of science where the decision stakes are very high, the system's uncertainty is also very high, and the values are in dispute. And decisions on these things are often urgent as well. And it's very important in these situations of postnormal science to include broader participation in the characterization of the problem and in how to respond to it. So, for example, the authors of the postnormal science argue in favor of involving an extended peer community. Others have argued in favor of normative, substantive, and instrumental rationales for broader participation from publics and stakeholders. So these are the normative principles that it would be better for democracy if we include more people in the discussions. Substantively, it would lead to better decisions, and instrumentally, it would lead to greater legitimacy of any decisions that are made. Others have argued for regulatory cultures of participation in the face of different types of uncertainty. So we're not facing an issue of basic risk here. This is something that is highly uncertain, and as Andy Sterling has argued, ambiguous or even ignorant. And in all of these cases, these are all rationales for including public participation, wider stakeholder participation, and so on. And what this stops from happening, essentially, is lock-in to pathways or decisions that we may later regret because of poor information or just conflicts that may well arise from the different values that are contested throughout these issues. Okay, so we're moving on to some work that I've been doing for the past few years, really, which has been exploring the ways in which climate engineering debates have essentially been closed down. And what I mean by this is that participation has not been particularly broad, and very narrow framings have led to this closing down, essentially. So firstly, we've got the contextual isolation of climate engineering. So, as I mentioned before, the primary rationale for this is that mitigation options and adaptation are both insufficient for responding to climate change because of a climate emergency or because things aren't happening fast enough. And so this kind of places climate engineering in this unique position where it might be able to get us out of this mess. But of course, those are only particular ways of understanding the problem, and it's important to resituate climate change back in that context with mitigation and adaptation. As I mentioned, there's been virtually no participation at all on this issue. There have been some recent exercises here in the UK, of which I've participated in, but what we need is more of that. There's also the issue of analytic deliberative integration. And what I mean by this is that although participation is important and science is important as well, you see very few examples of the two things being integrated. And they come from two very different epistemological or knowledge standpoints. And bringing these two things together will be mutually strengthening and better for policy making in general. Another issue is that engagements with climate engineering have been quite what we call unreflexive, in the sense that they haven't reflected on the kind of assumptions and motivations that go on in assessments of climate engineering. And finally, through that, the adoption of narrow framings have led to closing down on particular climate engineering options for tackling climate change, often recommending something called stratospheric aerosol injection. That's the most controversial one, arguably, as the most suitable or optimal response for tackling climate change. And so what we can see on the graph there essentially is a list of all of the climate engineering options that have been considered thus far, and at the head of the pack is stratospheric aerosols, which I believe has been appraised on average about 3.5 times more often than other proposals. So just to give you a little example of what I mean by this kind of narrowing down on framings, the Royal Society produced a seminal report on climate engineering back in 2009, where they did a preliminary assessment of the technologies, and they used 4 technical criteria: effectiveness, affordability, safety, and timeliness. And in doing this, they privileged 2 of these criteria on axes for a graph. So this is the first, I'm not sure how well you can see that, but on the first panel graph there, you can see the assessment that they came up with. And it quite clearly places stratospheric aerosols in the top right-hand corner, which is exactly where you would want your option to be if it was going to be the best one available. But this, of course, is just one of 6 possible permutations of just these 4 technical criteria. And under these different framings or ways of looking at the issue, you can see that stratospheric aerosols don't always come out on top. When you privilege safety, it does quite poorly, and air capture and storage does quite well. And if you privilege safety and timeliness, and under a number of other criteria as well, afforestation comes out top as well. So it all depends on the framing, essentially. And as you can see, also, the treatment of uncertainty in this issue has been quite inappropriate, in the sense that they've put kind of small arbitrary error bars which are not reflective of the true scale of uncertainty that we're dealing with here. So some of the work that we've been doing has been seeking to kind of respond to this closing down on climate geoengineering options. And it's all been about opening up to alternatives and resituating climate change in the broader context of mitigation and adaptation. So what the lessons from previous assessments are, essentially, are that we need to open up the context, we need to include diverse perspectives, and we need to be reflexive about that. And we deployed this through a technique called deliberative mapping, which is an analytic deliberative integrative method that brings together 2 strands of work, one for specialists, so experts and stakeholders, and one for members of the public in our citizens strand. And these involved interviews for the experts and citizens panel workshops for the members of the public. And they came together uniquely in a joint workshop halfway through the process, where the citizens were allowed to challenge the views of the specialists. Essentially, it's a multi-criteria approach, which involves the definition of options, then the formulation of criteria with which to then appraise options, and then you can see the performance of the options relative to one another. So rather than just looking at climate engineering, what we did was look at alternatives. So we've got a range of climate engineering ones to begin with there. We've got biochar, air capture and storage, stratospheric aerosols, iron fertilization, cloud albedo enhancement, space mirrors. But we've also got mitigation alternatives. We've got low carbon living, renewable energy technologies such as offshore wind, a new market-based mechanism, nuclear fission energy, nuclear fusion energy, carbon capture and storage on a coal power plant, and carbon tax. And we also included business as usual as a baseline for this. And it was also open for the participants in the study to identify their own additional options at their own initiative. So one of the first things we noticed after coming out of this process was that we got a lot more criteria to contend with. So, for example, one thing that's often focused on in assessing options for tackling climate change is whether, or to the extent to which it reduces global temperature, which is of course a very important criterion, but it is just one of a much broader range of criteria that fit within this efficacy category. So the criterion that we choose to assess with under this category has very important impact on the kind of outcome that we have at the end of the day. So if you're assessing something in terms of global temperature reduction, you might find that stratospheric aerosols does come out on top, but the alternatives include whether they reduce greenhouse gases, which in the case of stratospheric aerosols means that it would perform very, very poorly indeed, because it doesn't do that. Other issues include climatic response time, whether it reduces impacts, and so on and so forth. So we've got a significant expansion of criteria depth in that sense. But we've also got a large expansion of criteria range. So we've got not just efficacy, technical issues of efficacy, environment, feasibility, and economics, but we've also introduced new ideas of politics, safety, society, ethics, and co-benefits as well. But one of the most important things that we can notice here is that not only did we come out with unique criteria for specialists, from specialists rather, but we also came out with unique criteria from citizens, which really underscores the importance for doing these kind of analytic, deliberative, integrative processes, because there are things that specialists miss. And by including both of these things together, it will make your conclusions far more robust. So what we have here is the performance map of each of the options that we assessed, well, just the core options here. Just to explain this a little bit, we had 4 different types of group of people. We had academic experts, civil society stakeholders, industry, government stakeholders, and then we split our public groups into male citizens and female citizens. And what you can see there is the little acronyms, VLC and so on, they start off being mitigation options for the top 3, and then below that we've got geoengineering options, and then finally business as usual. And uniquely, compared to other types of assessment for climate change options, or any options even, it doesn't come out with a single score of performance. What this method does is it looks at the range of uncertainty that different participants might have on an issue, and the range of variability between the different perspectives that are bearing upon that. So this is represented by the large error bars that you can see. And the longer that bar, the more uncertainty there is. Generally, the further to the right on the chart, the better the option is performing, and the further to the left, the worse the option is performing. But the first thing we can notice is that there's quite a lot of uncertainty there for all of these options. And that's right that comes out, because often in these sorts of assessments, you'll come out with an assessment that shows particular options to be clearly the best option, but that doesn't show you the full kind of range of uncertainty that's beneath there. And secondly, and more remarkably, what we found was a remarkable degree of consistency in different perspectives that participated in this study. You can see a kind of slight angle on all of these charts, which is basically showing that the mitigation options are generally performing much better than the climate engineering alternatives. And the one exception to that is the industry stakeholders, who are more convinced that particularly the carbon dioxide removal technologies are more performing better. So the bottom line results that came out of this process show us that we had 3 highest performing options: low carbon living, renewable energy technologies, and large-scale afforestation. We also had 4 clearly lowest performing options, and these were all climate engineering options: stratospheric aerosols, iron fertilization, and space mirrors. In fact, they performed so badly that they performed alongside business as usual, which begs the question whether it would be worse or not just to carry on as we were, or to actually start doing any of these things. And then finally we had a more ambiguous performance from the remaining 8 options. But for the ones that are performing highest, interestingly, these are things that we could be doing right now, locally, without the need for a global agreement. And the findings that we have from this process, through having looked for disagreement, having looked for a divergence of perspectives, and then finding that we've got this convergence, actually makes the results much more robust, and has corresponding implications for how we should go about appraising options for tackling climate change more generally. So we've got a number of governance implications for how we should go about tackling climate change. The first of these is that we need to gain reflexive foresight of the imagined futures that in which climate engineering or alternative options for tackling climate change might reside. And this needs to be done inclusively, which will engender more democratic responses. So through the criteria that we developed, particularly the efficacy criteria, we could see that there were particular visions for what sorts of problems these options were seeking to tackle. And when you've got a very narrowly framed one, such as reducing global temperature, it ignores the whole range of alternative actions that people might want as well. Secondly, there's the issue of the optimality paradox. And this is the idea that in assessments, generally the best performing options, or the most optimally performing options should be the best ones, right? But often when they're implemented in reality, they don't perform very well at all. And this is where the idea of robustness comes in, which is that by considering this broader range of criteria and perspectives, you will have more robust decisions, but also you'll be able to identify more robust options rather than ones which are ostensibly optimal. And finally, responsible frameworks will be what determines the legitimacy of any pathway that we choose to take for tackling climate change, and also the flexibility with which those options will be governed. So this is a reference to emerging responsible innovation frameworks, which call for the anticipation of impacts that options might bring. It calls for reflexivity, it calls for inclusion, and it calls for responsiveness. So I'm going to try and bring together some lessons for Paris now. Firstly is that bringing in more perspectives is good for democracy. It leads to better decisions, it lends legitimacy, and it is the only suitable response to issues such as postnormal science, indeterminate uncertainty, ambiguity, and ignorance. Secondly, looking for disagreement doesn't necessarily preclude agreement, funnily enough. Divergent perspectives can actually show a convergence of opinion, and any conclusions drawn are necessarily more robust because of that. And so too can we identify the more robust options. So I think what we need to do is radically rethink climate change policy. I think we need to recast the problem. So we need to cast out the effectively unattainable and collectively undesirable goal of seeking a global agreement. We need to go back to the beginning and inclusively reformulate it as a problem. And there's some further reading if you need something to help you sleep.
We do have some time for questions, so if I can have an extra minute. Richard, if you could wait for the microphone. This is being filmed, so I should, if you don't want to be filmed, please wait and ask your question afterwards.
It's on, is it? Thank you. Richard Darton, I'm an engineer. So Rob, I'd like to take issue with your last conclusion, if you would like to go back to that. I expect you were expecting that somebody would object to this. Because it seems to me that you've shown quite neatly that there is going to be a question at the end of this, by the way.
Okay.
You've shown quite neatly that with the public engagement, there was substantial amount of agreement that what we need to do is use less carbon-emitting fuel, renewable energy, and possibly reforestation. And you pointed out that we could be doing all these things now, and of course to some extent we are, but not much. It seems to me that one of the major reasons why we're not doing these things is because we lack an agreement that climate change is serious and politicians need to get engaged. And from that point of view, it seems to me that getting some sort of agreement on climate policy is essential. Otherwise, people won't take these desirable options seriously and we won't be doing it. So I'm full of alarm at the idea that we should be suggesting that we don't need agreement, because somewhere we need agreement, possibly not Paris. So do you have an alternative way whereby we can get the public to agree, not just the great British public, but kind of worldwide? How do we get agreement that this is a really serious problem and we need to do something? That's the question.
It's a good question. So, yeah, I mean, the problem, of course, is fundamentally that people will never agree, rather, because of the kind of the cultural types of perspective that I introduced at the beginning. These are fundamentally opposed, and that is endemic. But one thing I didn't mention, but this is something that Professor Rayner, who can pitch in if he likes, will be talking about in a few weeks' time, is the idea of clumsy solutions. So what we've got with Paris and with Kyoto before it is something called an attempt at elegant solution. So it's based around a single framing, a hierarchical one. A clumsy solution would account for all of the different ways of organizing social relations. So at least the active ones anyway. So that means it needs a combination of hierarchy, it needs a combination of egalitarianism, it needs to include individualism as well. So by including all those things, we can get there. And Steve's in a much better position to talk about this than me in his Hartwell approach to tackling climate policy. But essentially, I think you'll never get anyone to agree. So trying to convince the public as well, that's a separate issue, is trying to convince people about science as well. It's kind of based on something called the deficit model of science communication, which is that the idea that if we give people the relevant facts, they will change their minds and everyone will be on the same page. But also, cultural theory tells us that no matter the facts, if you present them to 4 different types of person, for example, they'll give you 4 completely different responses as to how they interpret that information. Yeah. Does that give you a...
I'm not sure that I feel any more hopeful, but that could be realism, I don't know.
Okay, please.
Thank you. Hi, it's Robert Chris from the Open University. Robert, you talked a lot about geoengineering, climate engineering. How significant a contributor to this package of responses to climate change do you see geoengineering as a totality being, both in terms of SRM and CDR? And what sort of scale do you envisage these technologies being undertaken at? Because it seems to me that talking about these technologies without addressing scale is tempting people to be very misled. I mean, just to give you a very statistics that I'm sure you're familiar with. I mean, in the AR5 IPCC report, they're talking about 15 gigatons of carbon equivalent emissions in 2013, I think it was, which is equivalent to 50,000 million tons of carbon dioxide in a year. Now, if we're talking about sequestering a significant chunk of that, scale matters. So these technologies are all kind of there, but how big a deal are they and how realistic are they at scale?
Yeah, so I mean, one of the reasons I've tried to kind of tentatively draw some links to how we should approach climate policy more generally is that I think there's an important comparison between trying to seek a global agreement and trying to do climate engineering in many ways. And that is that for solar geoengineering, for solar radiation management, at best, what you'll need to be able to do that is a global agreement. But at worst, it could be done unilaterally by one nation because it's so cheap. But it would have global impacts or implications. And for the carbon dioxide removal side, you can't effectively do it without a global agreement because you've got the collective action problem. So no one's going to kind of go and altruistically do a bit of air capture at their cost, which is a very expensive technology at the moment. if it was done now. So yeah, scale, it almost needs to be global for it to work in many ways, with the exception of things like biochar and afforestation, which can be done more locally and more piecemeal, but also more importantly because they've got co-benefits. So air quality, for example, soil enhancements and things like that. So does that answer your question?
Well, it doesn't entirely answer my question, just picking up that last point.
Yeah.
If you are, for example, doing biochar, perfect example, at a local level, what makes you imagine that it would be done at sufficient scale in aggregate to have any climate significance?
Sure. Well, I think one of the kind of problems in discourses about climate engineering actually is, although it's kind of inherently large scale, is that it's assumed that they have to be done at a huge scale. I don't see any reason why we couldn't be pursuing a number of these technologies at more modest scales than some people might suggest. So in particular, I'm referring there to some of the more kind of less controversial carbon dioxide removal techniques.
Yeah, Steve Rayner. Rob, I'm going to try and help you out a bit with Richard's question and then dump you in it with another one. Richard, I think the point is that a very famous American political commentator once said that democracy is not about getting people who think differently to think the same way, it's about getting people who think differently to do the same thing. And the problem with Kyoto is nothing is, and the framework convention architecture is basically nothing is agreed until everything is agreed. And we've not got to the point where everything is agreed. So we've lost actually nearly 20 years in which we could have been doing incrementally much more if we hadn't committed ourselves to this idea that you need a central agreement to do a lot of things that can be done at the national and subnational scale. That is now beginning to be recognized. It's a pity it wasn't recognized 20 years ago. And I think that's the basis of what Rob was trying to get at. Now for the dumping you in it a little bit, which is I want to take issue with number 3 there of your lessons, if I may, Rob. Bringing in more perspectives is good for democracy, yes. Leads to better decisions. I'm not necessarily sure. Decision theory and decision science generally shows that the more participants you have in a decision, the lower the common denominator that you end up in terms of what you get a commitment to. So I would be interested in how you deal with that internal contradiction in that claim.
Sure, thanks. So do you mean kind of, in terms of forming a consensus, they'll go for the lowest kind of? Yeah, so in a lot of public participatory processes, you'll get attempts to form a consensus view. These include methods such as consensus conferences and things like that. And Steve's absolutely right to say that. They do often come down on the kind of least common denominator that everyone can actually agree on. But where the kind of method that we've adopted here, deliberative mapping, where that differs to those sorts of methods, is that rather than seeking to reach a consensus as such, it actually sets out to look for the disagreement in the first place. And so when you find that people are actually agreeing in such a process, it makes the options that perform well in that process all the more robust.
Okay, there was a question in the row in front of you there.
I'm Victoria Wiebeck from Linköping University, Sweden, and also visiting INSIS here. Thank you for a very interesting lecture. And I had a question about methodology for the citizen panels, because I've been running focus groups in Sweden on climate engineering, and we found that people were very good at discussing some of your criteria with very little information, because Sweden is a country where there is hardly no debate about climate engineering. And our participants were very good at discussing the ethical, the social aspects of it. But of course, it always depends on how you frame climate engineering, which aspects will be brought in. So I was wondering if you could say something more about how you framed climate engineering options to your participants and what type of information they were given.
Sure. The way we kind of, for the public strand, when we recruited the people to come along, we didn't call it a debate on climate engineering or anything like that, or even on climate change. We invited them on the assumption that it was a discussion of global environmental issues. Then when we got them in the room, we started talking about global environmental issues. And what we wanted to do was, so this is some research that I've been doing with Javier Lazan at the Institute as well, which is about this idea of unframing. So you're quite right to say that framings lead to particular outcomes. So what we wanted to do was present them with no framing, essentially. So we introduced them we allowed them to talk about global environmental issues, and climate change kind of naturally emerged from that process. And then we started talking about options for tackling that issue, and some of the participants even started suggesting things that might be considered as climate engineering, even though they might not necessarily be them at that time. So they'd already started thinking about it in that way, so it kind of naturally emerged. Then we kind of formally introduced it as one of 3 main ways of responding to climate change, so alongside mitigation and adaptation. And one of the kind of interesting kind of things I'm sure you're familiar with in kind of presenting people with information about geoengineering is the pictures that you use to show them. So I'll just go back actually and show you some of the pictures. These are the pictures that we used in our process. Some of these things are things that do exist, like trees, for example. But on the other hand, things like stratospheric aerosols, mirrors in space, and perhaps most interesting in air capture and storage, they're all what we social scientists like to call socio-technical imaginaries. So they're basically an artist's vision of what these things might look like. They probably won't look like that at all. But the important thing is that by presenting an image like that, you evoke a particular reaction. So looking at the air capture and storage one, which is at the third from the left on the bottom, it shows a particular vision from a company called Carbon Engineering, which is based in the United States. And their vision of this technology is something that looks quite like a large air conditioning unit. But other people have come up with things which look like artificial trees, which evoke a very different kind of reaction. And on that related note, artificiality and presenting things as natural or unnatural also has a very important impact on the way people perceive things. So some colleagues of mine at the University of Cardiff have done some really important work looking at naturalness framings. So when you present stratospheric aerosols as like a volcanic eruption, when you present air capture and storage as like artificial trees, when you present biochar as a natural process, these things unduly improve the way in which people perceive these technologies. But interestingly, you could frame all of these things a completely different way. So stratospheric aerosols is putting sulfuric acid into the atmosphere, it's very chemical driven. Air capture and storage is a massive air conditioning unit. And biochar is a very industrial process during its pyrolysis component. So yeah, framing is very important.
Okay, there was a question over by the window, and then we'll go there, and then there's 2 more at the back.
Thank you. My name's Lucy Ford. I'm from Oxford Brookes University. I'm wondering if you could put it back onto the lessons slide. I mean, I can probably just about remember. I wanted to comment on your last point about abolishing the global collective agreement and going back to the beginning. What's the beginning? And has the Kyoto process, has the UN Framework Convention on Climate Change got the problem wrong if we need to reformulate it? And it relates also to your sociocultural model, which I agree there are lots of different ways of framing things, and that is part of the complex society we live in. But could you underlay that with an analysis of power as well? So, some theories are dominant for certain reasons, other theories are marginalized. So different ideologies come into play. There are different structures that share the information. There's media that biases or gives certain information and not others. So if we are going to have a global democratic or even a local democratic process of reformulating something, how are we going to do that? And how are we going to ensure that it's truly democratic? Thanks.
This is the awkward one, this one. So I mean, I kind of, this kind of last point is really a kind of a point of departure rather than a conclusion as such. I think it's certainly up for grabs as to how we go about to do this. Sorry, what was the first point again? It was.
What is the problem?
Yeah, so the problem, I mean, one of the main problems is that the global agreement itself has been formulated as a very kind of particular way of formulating the problem. It's a very hierarchical way of doing things. And it ignores the other ways of tackling issues. And because of the fact that we know there's this endemic disagreement, trying to pursue something like that is only going to, at best, be a waste of time. So I think in terms of going back to the beginning, we need to, we just need to stop doing the global agreement attempts and think about things in a more local sense. Like I say, there are things we can do at the local level right now that have important co-benefits. And again, this is kind of preempting a little bit of what Steve's going to talk about in a few weeks, which is that there are ways of tackling climate change obliquely. So there are ways of thinking about it and responding to it in ways that aren't tackling climate change directly, but have climate change co-benefits. So one example of that would be tackling air pollution, things like that.
Okay, we had a question there at the back.
Thank you. My name is Jana Rosen. I'm an environmental consultant, and I'm also a research associate at the Environmental Change Institute. The way I understood your methodology is that you have an ability to compare different options where you have disagreement. Different groups have disagreement on what's the best option. And I understand that, I get that. What I'm not so sure about, how well suited is your method to address the more fundamental disagreement about whether we should actually do anything about climate change, which still seems to be unresolved. If you ask the wider public, you still have quite a high proportion of people who say, well, we shouldn't do anything. We don't need to look at different options. Actually, it's a more fundamental issue around, do we have to do anything, or do we just do business as usual? So how well suited is your method for addressing that?
Sure. I mean, we kind of incorporated that perspective through the inclusion of the business as usual option, which was perhaps not surprisingly one of the 4 lowest performing options. So you're absolutely right to say there are a considerable number of people, some with very loud voices, who say that we shouldn't be tackling climate change at all, not even obliquely. But what this process has shown is that by pursuing doing nothing, I mean, it's obvious really that it's not going to leave us very, very well off. But what's more interesting is that some of the options that are being considered to do something are potentially just as bad as doing nothing in the first place.
Okay, there's another one at the back there.
Hi, I thought it was interesting and rather telling that industry was the only set of stakeholders who felt very differently about the preferred options. So firstly, did you do any research into why they felt so differently? And secondly, how did you think at all about how you would try and incorporate an industry perspective and get some consensus with other stakeholders when their preferred options are so markedly different from everyone else?
Sure. So, so the reasons why perhaps these technologies, the air capture and storage and biochar, perform a little bit better with the industry sector is perhaps not surprisingly because that they have more of an opportunity for being commercialized. And a colleague in the United States, Professor Ken Caldera, has just written a piece about how these technologies might be commercialized. So for industry, these are opportunities that things like voluntary low carbon living might not be able to, it doesn't have a place for them really. Referring back to cultural theory again, it's what we would expect from a more individualist perspective, is a gravitation towards these sorts of solutions.
Tim was putting his hand up.
Thank you very much. Tim Kruger, Oxford Geoengineering Programme. Rob, obviously how you frame things is one of the problems in this kind of thing. It's also the amount of information that you give about particular techniques. Now, obviously, I don't know how afforestation was described, but one of the reasons why afforestation is attractive, apart from naturalness, is improvement in biodiversity and the like. But the reason why there is potential for afforestation is because we have chopped down a lot of trees. And the reason that we have done that is to increase the amount of land available for growing crops. If you reverse that process in a forest, you reduce the amount of land available for crops, and that has impacts on food supply, food security. I'm guessing that wasn't something that was raised in the discussion of afforestation as an option. And so I guess my question is not to kind of criticize that, but to say, how do you deal with the incompleteness of information about proposed techniques? Because if you supply that information, it can have a very marked effect on the attractiveness of such an option. And so you're drawing a conclusion on the basis of some information, but then how robust is that conclusion? Because the information that you're providing is incomplete necessarily.
Yeah, absolutely. That's a really good point. I mean, the participants, they did discuss the issue of land use conflict, which is particularly pertinent for afforestation and some other land-based climate engineering proposals. But there are blind spots. No kind of single process like this can cover everything. What we've tried to do is cover more stuff than other assessments. So, for example, if you do an assessment of technologies in terms of I'm sure my colleague Nem Vaughan and Tim Linton won't mind me referring to their assessment of radiative forcing potential for different options for tackling climate change, which is essentially how much it can reduce global warming. By looking at that, you can come out with a very clear picture of what option is most optimal, stratospheric aerosols, but there's a big blind spot. Processes like this, incorporating more perspectives, more criteria, and so on and so forth, it gives you a more realistic picture. So what I'd say we need to do is do more of this, and so we can have a better informed picture, not only here in the UK, but also worldwide. I mean, some of these things, these technologies have global, well, all of them have global implications, particularly the solar radiation management techniques. So engagements with publics and specialists elsewhere is crucial.
Sorry, Rob, just a couple of comments really. First of all, I think that this exercise is hugely flawed in a whole range of ways, but I think it's absolutely essential that it be done because it's the first pebble in the pond. You have to start somewhere, and you can't achieve everything in one, in the first outing. And I think it's absolutely right that one begins this process, and hopefully it will extend. And I think the last comment you made about it becoming international is quite critical, because obviously this is a global affair, and one needs to extend the community that's actively engaged. But the thing I really want to get to is I want to come back to these various comments about the framing of the issue, and your last, the third element of your Paris slide, your final slide. You've mentioned several kind of the sociology buzzwords. You mentioned clumsy solutions, and you mentioned postnormality, and so on and so forth. One I think you didn't mention was wickedness.
Yes.
And there is a whole stack of stuff you know about wicked problems. And one of the key points is that climate change is a wicked problem. And for those that aren't familiar with it, essentially means that it's a problem that you can't properly define, and there's no stopping solution. If you address it, you don't know when you've actually solved it, because it keeps changing with each intervention. So the problem never actually gets sorted. And one of the issues for me, and I'm interested in whether you would agree or disagree with this, is that the problem that we have with the way that the whole climate change discourse has been conducted is it's been presented as if it's a tame problem, as if it is a problem that has a solution. And in fact, what we ought to do, I would suggest, is to abandon talk about the problem and just talk about the situation that needs to be managed. And that opens up a whole range of other interventions and stops us having to think about the big solution, the thing that's going to crack the nut. Because whenever you think in those terms, the scope of it is just too big to grasp. And whether you would care to make some comments on that.
Yeah, well, I completely agree with you. I think, I mean, and this links back to the kind of the post-normal science as well. So wickedness, it's all about problems that can't be very well defined and keep changing and things. And normal science will never be able to help us there. I mean, it's part of the solution. You've got to do a bit of science, but you've got to think of it in other ways as well. And in that sense, the kind of clumsy solutions, and another phrase is the kind of use of a silver buckshot of options rather than the use of a silver bullet. So we've got to use lots of different options. And yeah, I completely agree. We should stop talking about it as a problem. Yeah.
Okay, I think we've got time for 2 more questions. We have a lady here, and then the final question at the back there.
Hi, thank you. I'm Danielle Young. I'm a PhD student at Aberystwyth University, and one of the things, I think the thing that struck me most is when you have the grid of the kind of 4 different ways of thinking about the problem and what kind of people you're talking about, I feel like one of the things, building off of another question that was asked, that's missing here is the power dimension. Because especially when you're looking at something like hierarchy, the risk is acceptable. Who is calculating the risk? Because I think there's actually what's missing here is that the risk is acceptable for some, and that actually kind of changes what you're looking at and who's going to be willing to be fatalistic about the problem, who is thinking in terms of hierarchy. And I think, I mean, I appreciate what you're trying to do here, but I think in terms of bringing in more perspectives, you also have to account for the fact that some of those perspectives are going to be much more powerful than others, and how do you address that problem? Because while I think, you know, going for an elegant solution is problematic, you can't have everything. The whole idea that you should, you know, do sort of piecemeal efforts kind of takes the burden off of people or interests that are more powerful and probably doing more damage, and kind of distributing it to people who are not necessarily, they may be more at risk from the problem, but not necessarily the ones that need to be put in the position of solving it, if that makes sense.
Yeah, no, totally. Power is everywhere, as someone quite famously once said. And yeah, as we can see with the formulation of climate change as it currently stands, the power is firmly with this kind of hierarchical position that it needs to be a global solution to a global problem. And one of the ways that we try to manage the issue of power, actually, in our deliberative mapping process, was through diversity and through symmetry. So, with the inclusion of diverse specialists, so we didn't just have climate scientists, we had different types of natural and social scientists with different views on different options for tackling climate change. We had different representatives of the industry sector and different representatives of the civil society sector and of government at different levels, local, national, international, different members of the public as well. So the key to guarding against power is diversity, and that's really what we're trying to do there. And the symmetry component is is how we have these kind of two parallel strands for specialists and citizens. And one thing we tried to do in the process during the joint workshop component is that we tried to actually invert expected and normal power relations by, rather than, I mean, one of the kind of issues in public deliberative processes is that members of the public, if there is an expert present, they will defer their view to the expert. But what we tried to do here was completely invert that, and we got the citizens to interrogate the expert positions and got them to try and justify their positions on this. So yeah, power is incredibly important. Diversity is the key to managing it, and we hope to sort of try to address that a bit in our process.
Thank you. There's a last question in the corner there. Hi, my name's Dadu. I'm a recent graduate from UCL. My question is also about the sociocultural theory grid that you showed. I was wondering, because you seem to suggest, just to use your phrase, lock-in, that people are fairly rigidly associated with a certain position on that grid. But if you read a book like Wrath of Capital by James Parr or David Harvey, they suggest that the rise of neoliberalism has perhaps shifted people's cultural identities, changed the nature of social capital in certain societies to the extent that perhaps people move across around the grid. So I was wondering, perhaps maybe as a solution we play on that flexibility.
Yeah, absolutely, and that's a really important point as well. It's quite a common point of misconception when it comes to cultural theory, actually, that there are these four worldviews that people kind of hold stably, and it's important to note that there are two kind of interpretations of cultural theory. One is the stability hypothesis, which is often how it's understood, which is that people hold these particular worldviews and they'll try and reproduce the way they think in different realms of social life. But the other way of thinking about it is in terms of a mobility hypothesis, which is that people do change these views in different times and contexts. And there's been a lot of research to show that is exactly how it takes place. And that depends a lot on the kind of social relations that are taking place. So if I'm trying to build a relationship with you, for example, and you're taking a hierarchical position on a particular issue, I might change the way I'm speaking to kind of build that bond. So they do change in different times and contexts.
Okay, thank you very much. Before we close, I did say that it's a long series on climate change, and I do urge you to check out our website because we have events on climate change and biodiversity, climate change and human rights, climate change and water, and many others. Just to draw your attention to the next two, same time, 5 o'clock next Thursday, we have Professor Gideon Henderson and Professor David Marshall both addressing climate change and our oceans. And the following week, we have Professor Sir John Beddington, who is the former Chief Scientist to the UK government and is now Senior Advisor here at the Oxford Martin School. He'll be talking on The Perfect Storm Revisited, food, energy and water security in the context of climate change. And away from climate change, we have three very interesting events coming up. Chris Lintott, Professor Chris Lintott, who is now the BBC astronomer on the sky at night, will be talking about Feli at the Comet, a scientific adventure, so about that amazing story, and that will no doubt be an entertaining event. That's Tuesday the 24th of February at 5 o'clock here. On the 2nd of March, we have Dame Sally Davis, who's the UK government's Chief Medical Officer. She's talking about the infectious threat of antibiotic resistance, and that's called a ticking time bomb. And that will actually, that will be at the examination schools because there are expected to be a lot of people. So if you are interested, please do go to our website and register quickly. And lastly, just to draw your attention, Wednesday the 4th of March, we have Professor Vlatko Vedral, who leads the Oxford Martin programme on bio-inspired quantum technologies, but he's very able to talk about quantum to the layman, and he will be talking about living in a quantum world. So if you're interested in learning a bit about that, do come along again at 5 o'clock here on Wednesday the 4th of March. So to close, I'd like to just thank Rob again for an excellent talk.